गाइस टीम चैट जीपीटी हेयर एंड हम आपको आज सोल्यूशन दिखाएंगे फॉर द प्रॉब्लम स्टेटमेंट स्मार्ट ट्रैफिक परसेप्शन दैट वाज प्रेजेंटेड इन द क्रैक हैक 2025 hackathon. This web page is our solution. This web application is our solution. Our team consists of four members: Krish Bhagat, Harmanpreet Singh, Ayush Chauhan, and Nishant Kaushik. So how what our web page does is it takes input from the user in form of either a MP4 file or you can upload a YouTube URL, and it's gonna show you the processed video along with the feature of live traffic count. So what this is it's a live graph which is gonna show you the amount of vehicles and the amount of pedestrian per frame. At the end you can also has a download csv function which downloads a csv file which has the frame by frame data, which consists of the amount of the count of each class in each frame. We're gonna see what that is. So let's start here. I'm gonna paste a YouTube link. It takes a little time to upload, but you can see the result is very smooth. It is not only able to detect things that are near, but it is also able to detect things that are quite far away, vehicles that are quite far away. It is possible due to our dual model architecture, which we're gonna come to in a while. And here you can see the traffic count of the last frame. Let's click on the download csv option, and here is the output csv file. यहाँ हम लोग देख सकते हैं कि हर फ्रेम में डेटा दिया रखा है हमको कि क्लास कार के 4 काउंट थे और उनकी पोजीशंस ये थी. फ्रेम फोर्थ में एक पर्सन था और उसकी पोजीशन ये थी. एंड वी हैव दिस डेटा फॉर ऑल द फ्रेम्स इन द video. This data can be useful in many ways, especially when it comes to city and road planning. And another great feature which I'm going to show you is we can see that feature clearly in this video. So I'm going to upload a mp4 video that is saved locally on my computer, and here you can see that it is showing this person near road tag for people that are near the road. It is a safety feature that we added. We thought it's a good feature. And you can see that the video is a bit laggy, and it is a problem that is there in these kind of high resolution videos only. You can see that it is not detecting these people because they are not near the road, but for people who are near the road, this works great. It can be a great tool for accident prevention. And let's now look at the code. Here is the code, and here I'm gonna explain you the model architecture. We are using two models here, primary model and secondary model, and we want that if the user has CUDA installed in their computer, then it should use the GPU resources. If not, then it's going to use the CPU resources. So coming back to the model, we have a primary model which is a YOLO V8N, and here stands for nano. It is a model that is small but very fast, so we're going to use it as a primary model to and run it on every second frame. And other model is a secondary model which is a YOLO V8 medium model, which is a larger version of this YOLO V8 model, and it is able to detect things with great precision. And here are the class names, and we're going to select certain classes only. We don't need all of those classes. We assign different color to each class, and here we are taking the object data in a pandas data frame because we want to write it later in a csv file. We are using the ydl module here to bypass the download restrictions put up by YouTube, and there is the function for downloading YouTube video, calculating road region so that the person near road function can be implemented. And here is the main function, the process frame function, and here we can see that the primary model is running every second frame. because it is a small model, and we basically run it so that it enhances the speed of recognition, and the video output video is smooth. And here the secondary model is running, which runs every fifth frame. It runs in order to detect the things that are far away and things which are clustered together. In the case of conflict between the primary and the secondary model, the primary model is preferred. So if both primary and secondary model detects object, then the primary model is gonna get the upper hand. Here we can see it's the whole function. We have an is csv ready function, so that it the download request is sent only when csv file is ready. And here is the generate frames function, which generates the frame for our output video. There's our upload file function, and finally here's our download csv function. Let us look at the github page now. Our github page has all these files, so if you want to run this web app on your device locally, so what you're going to do is you're going to clone this github repository. You're going to pip install the requirements.txt file, and then you are ready to go. You just run the Flask app and copy that URL link that you get there on your local browser, and it's ready to go. Here in the readme file, we can read all the features that we have implemented in our model, with advanced object detection with YOLO V8, real-time object tracking with DeepSort. DeepSort algorithm is used to track objects so that the framing is smooth. Optimized performance with multi-threading. We have implemented threads in parallel video frames because we are running two models here. Class specific labeling, structured data export and analysis, and web based dashboard for visualization. Architecture, here we have a video processing pipeline, and this is what I explained earlier for the architecture. Web interface and visualization, this is the repository structure, and here is how to set up this on your local. And if anyone wants to contribute, then it's most welcome to put a pull request. And that is it from team chatgpt. Hope you like our project. Thank you.